changes. Turn and face the strange changes.
Hi everyone. So sorry if you weren't able to make class today, or welcome back if you just want to review what we went over again. So on Thursday and Friday, first thing first, we've recently combined classes, so some of you might have an easier way to get our warm-up now. If you notice, the Bitmoji page on our Canvas classroom has a lot of links embedded. Usually you can get anywhere you need to get to from this classroom. So right up here where it says Thursday and Friday warm-up, if you right-click that and open in a new tab or a new window, that'll take you right to the warm-up each day. Also remember, if you left-click on the Zoom links, that'll just take you to the Zoom links page. Then the weekly assignments will take you to your modules. Well, actually, it'll show you all the different work, and it'll take you to your modules or to your assignments if you right-click. And really importantly is the past weeks, that calendar up there. That's where all of these notes are put as an easy to read document, and also the video that you're watching right now. So that's just an easier way to get your warm-up so you don't have to go to the side modules and find today's warm-up. So today's warm-up was asking you to dig deep and try to come up with some examples of physical and chemical changes. I'm not going to go over some of the answers. You guys made some really great guesses. You guys were really spot on for most of them, which I'm very impressed with because we hadn't actually learned it yet. But you guys made some really good guesses. Your homework over the weekend is to do the virtual lab. The lab observations is what it's called. And when you're done with that, but before you submit it, do your post-lab questions Canvas quiz. You still need to submit both, but I'll talk about why later you want to keep this one open before you submit it, before you submit the quiz. So we went over the warm-up. Then we had breakout rooms with the classifying matter activity. We took notes on chemical and physical changes and properties. Then we started that lab together. We started going over the demos, and I can go a little bit more in depth about those demos now than I was able to then. And then we went over the asynchronous work, so students knew what to expect. So in your breakout rooms today, you guys did that activity, elements, compounds, and mixtures. You guys were in groups of 3 or 4. And what I asked is while you were in your breakout rooms, that one person could share the document, and you guys could work together using the drawing tools or the shape tools to circle your selections, whether it was solid, liquid, gas, pure, or a mixture for each example. And even though it wasn't graded, I still asked for everyone to hit that save button, which is actually your submit button with Cami things. So I could just have a record to show me that yes, everyone did participate today. I purposely put this off until today's class rather than Tuesday because I wanted you guys to have a chance to do that practice quiz homework and to feel confident that you felt like you understood the answers so you could share the answers with each other. Then we went to our Unit 1 notes. So it might be a bit of an ordeal to find them, but I believe in you guys. You can do this. In our module, I posted a link to your Google My Drive because your copy of your notes that you've been writing in is saved in your Google Drive. So once you click that, it would take you to your Google Drive. One of the fastest ways you can find your copy of the notes is to type in Unit 1 Notes 2021. And I apologize, I didn't realize until today that you might have Unit 1 notes for other classes. So in the future, I'll say Chemistry Unit 2 Notes 2021 for you to go and look up. Hopefully you probably only have one document named that, one Google Slides document. You can open it there. Or if you took my advice and you made a chemistry folder and saved it there, you can just click on that folder to find it. So here in our physical versus chemical changes notes, we're page 5 of our guided notes slide. So I'm actually going to go in a slightly different order than they're listed here in the document. I'm going to go over the examples first. So some examples for physical changes are melting, freezing, boiling, condensing, any sort of phase change, anytime you're going from liquid, solid, gas, Those are all physical changes. Anytime you cut or crush something is a physical change, as well as any sort of mixing or dissolving. Those are all examples of physical changes. So, in a physical change, my chemical composition is not changed. That is not going to be changed if it's a physical change. So here is my example. I have liquid water. It jumped up a bit. It's not really anchored to the table. I have liquid water molecules. They are boiled to turn into gas water molecules. They're turned into gaseous molecules. It's water vapor now. So what changed here is my molecules were super close together, and now they're spread apart. But I still have big white circle, blue little circles. Big white circle, blue little circles. It's the same molecule, just it's spread apart. So my chemical composition is not changed. However, the appearance often does change. A pot of water looks very different before and after you boil that water away. Once you've boiled the water, you can't really see it anymore. I have this piece of Post-it paper. If I rip it in half, I've made a change. But I still have Post-it paper. It's still the same chemical. It's still the same substance. I just have a different size, but it's still just Post-it. Now, sometimes physical changes can be undone. Now, I can't quite fix my Post-it. It's kind of ripped in half forever now. But think about other examples. If I freeze water, if I fill an ice cube tray with water and put it in the freezer and make ice and, oh shoot, I wasn't supposed to do that, I can leave it out. I can leave that ice tray out of the freezer and my ice will melt back into liquid water. So I can undo that change. If I melt some ice cubes and, oh shoot, I did need that ice, I can put that ice tray back into the freezer and remake the solid water. So a lot of my physical changes can be undone. Now, chemical changes. So here my examples are rusting or corroding, burning. I enjoy burning, that's why we made it red. Reacting, decomposing, exploding. These are all examples of chemical changes. So down here, it's actually from our Model 3 homework, which hopefully everyone got in on time. I have oxygen molecules, so oxygen atom bonded to another oxygen atom, and hydrogen molecules, so hydrogen atom bonded to another hydrogen atom. Then they react and they explode, and they form a new substance. They form water. So in a chemical change, my chemical composition is changed. I had hydrogen attached to hydrogen, but then those chemical bonds were broken. Same thing with my oxygen. I took those atoms and I ripped them apart. And then I formed new compounds. I made new bonds. So I broke apart molecules and I made a new one. I've got white, white, blue, blue. But after my reaction, I have white, blue, blue, or blue, white, blue, depending on how you want to read it. So new ones are formed. When I'm making new bonds, that means a new substance is formed with new properties. Oxygen and hydrogen gases are very explosive. They like to mix and explode together, but water vapor will not explode for us. That's very harmless, very important molecule. And chemical changes can never be undone without another chemical reaction taking place. I can't make this go back into their old molecules without breaking those bonds again. And I've already done that a few times today, saying the rip really loud, so can't do that anymore. And then for my properties and matters, I have chemical properties and physical properties. My chemical properties, I'm going to have to change the identity of my substance in order to observe. So one example of a chemical property is whether or not something burns, whether or not it is flammable. I can really only test to see if something is flammable by setting it on fire. So the act of setting something on fire will change my substance. Seeing how it reacts with air, acids and bases, water, other chemicals are all chemical reactions. I will create a new substance when I do those things. So chemical properties can only be observed during a chemical reaction. And then my physical properties can be observed without changing my substance. I have a marker. I can observe one of its physical properties is its color. I can tell you this is an orange marker, and that doesn't change my marker in any way. Now, this is an intensive physical property. If I have a small orange marker or a big orange marker, it will still be orange. And extensive physical property depends on how much of the thing you have. So this marker is about 6 inches long. But if I have a really big marker, that length property will probably change. If I have a really big marker, maybe it's a foot long, maybe it's 12 inches long. So extensive physical properties depend on how much you have of your object. Intensive is just true for that substance, true for that object, no matter how much or how little you have. Water, for instance, will always boil at 100 degrees Celsius, whether you have a lot of water or a little bit of water. All right, after that, I had you guys go into your lab observation assignment. So it looked like this. And we just recapped again physical and chemical properties and changes. Physical properties are the ones that you can observe, you can measure. Chemical properties are ones that can only be observed during a chemical reaction. Physical changes are when you have a change in temperature. So if I put a heating pad in the microwave, it's going to get hot. That's just a physical change. If I put my drink into the freezer for a while, it'll get cold. That's just a physical change. I put it into a cold place or a hot place. Changes in size. So I had a full-sized Post-it note. Now I have 2 pieces of a Post-it note. I just cut or crushed it. And the physical state, so going from liquid to gas to solid, are just changes in states. Those are all physical changes. Chemical changes have occurred when a new substance is formed. And so some look-fors, the evolution of a gas. Did it make a gas in that reaction, in that change? Now, if you boil something, you'll see bubbles, you'll see a gas coming out of a pot of water that's being boiled, but that's still a physical change. You're not actually changing the water when you boil it. So if something is not boiling, but it is bubbling, that tells you that you are evolving a gas. You're making a new substance. So when you mix baking soda and vinegar to make a baking soda vinegar volcano, you are making carbon dioxide gas. That's what's filling those bubbles. A color change often means that you have a chemical reaction. Usually a color will appear to show you that you have a new substance. The formation of a solid. The formation of a solid where you did not have a solid product before tells you that you've made something new. Now, that's not the same as something drying out to become a solid or something to freeze to become a solid. This is a rather instantaneous thing. You did not have a substance, now you do. If you see rust forming on a nail, that is a new substance that was not there before. You're making something new. The oxygen and the iron are making iron oxide. And then the production of heat or light. If it is giving off its own heat, or if it is shiny and giving off light, that is a chemical reaction. So putting something in the microwave to warm it up is physical. But those hot hand packets that we use on cold days, you squeeze them and you shake them and it starts to get warm by itself. That's a chemical reaction. Anytime it gives off light, so like a glow stick, is a chemical reaction. So our first demo was magnesium ribbon. I'm going to transition myself in front of it again. It's kind of hard to make observations for certain, but we can make some here with the image. We can tell that it's a silver gray metal. Most metals are a little bit shiny. It appears here to be solid and a metal. It's very thin. It's a bendable wire, well, ribbon. We call that malleable for metals. When metals can bend, they are malleable. And so my change is I go and I'm going to put this into a flame. Here's an image of what it looks like in the flame. And here's an image of what it looks like after the fact. So here's where I stopped typing for a bit and I pulled up the video for us all to watch. So there it is. You can see here it's kind of shiny and straight. It can be straightened or curled. Now, a good thing is when we do this in class, I have to warn everyone to cover their eyes or not to look directly at the flame because it's bright. Look, it's so bright. The rest of the room in that video is starting to dim and it's giving off heat. Fun fact, it is hot enough to crack a glass watch plate. Now, I had a shiny gray metal. Now I have a brittle white substance. You can kind of see he's able to crush it with his finger. It's very brittle. It's very dusty. It's almost a powder. So what we saw, a bright light was emitted, a light so bright that it dimmed the rest of the room. We saw that a white solid was left behind after this was finished. And it also gave off its own heat. There was no magnesium ribbon left after the fact. So this is a chemical change. We know this was chemical. We saw light emitted. We saw heat was emitted. And there is a completely new substance with completely new properties. That is clearly not magnesium ribbon anymore. I have something new that I did not have before. Then demo number 2 involved copper 2 sulfate pentahydrate. So what pentahydrate means is for every copper sulfate molecule, I have 5 water molecules that are just kind of hanging out. They're not chemically bonded to the copper sulfate, but they are there. They're kind of like an overeager friend or puppy. You just want some time to yourself, but it's kind of hard to convince them to leave you alone. They're not bonded. That water is not bonded to those crystals, but it is there. So, some physical properties. It's blue. They're solid crystals. They're loosely packed. They're a little bit shiny, not like a shiny coin or a mirror, but they're crystals. So they have a little bit of sheen to them. Then what we do is we put them into a Bunsen burner flame and we see that color start to drain out. It goes from blue to white and we can see it change happening. When we do this in a test tube in the school, we can also start to see water condensing on the inside of it. Then, once it's cooled down just a little bit, we add some water back onto it, and then those white crystals start turning back to their blue crystals. So let me bring up the video. So there it is, solid blue crystals. Sometimes they kind of hunk together if you let them sit for too long. So it's there in an evaporating dish. Spreading it out so it's not too clumped, so the heat can get to it. And then I can see that white is encroaching on the blue crystals. The water is evaporating out of the crystals and the crystals are turning white. So now I have copper sulfate without any hydrate. And then once they start to put some water back in, this guy pours too much water. But I can see that blue color returns instantly. So what we saw is that as the water was evaporated out, it went from blue to white. And then as we added water back in, it went back to being blue. So this would be a physical change. What happened is that my water was removed, it was taken out of the mixture, and then my water was returned back to the mixture. It was replaced. So there was not a chemical reaction. It was done and then easily undone, that change. It was really just a mixture. I sorted out the mixture and then I remixed the mixture after the fact. So that's a physical change. I did say that a color change usually means a chemical reaction has taken place, but in this case, it isn't so much a new color appeared as so much as a color was taken away. Now, some hints that will help you out with the rest of the observation lab. It's kind of hard to come up with 3 physical properties of copper 2 chloride solution since you're not actually interacting with it. But I will tell you that it is an odorless solution. There is no smell from this solution. I would also like to tell you something else you would observe in this reaction is the speaker would start to get a little bit warm. That's one observation that you would be describing that you see or that you observe. I'm going to come back to investigation B in just a second. Investigation C, lead nitrate and potassium iodide, again, those solutions do not have any smell. They are odorless. Investigation D, chalk and vinegar do have smells. If you can remember what chalk smells like, or if you're lucky enough to have some sidewalk chalk in your garage, you can go and waft it carefully. Now, I listed here white vinegar, which is not necessarily what we would be using in the laboratory, but it's very similar. So if you have any kind of vinegar in your house, you can open the bottle and just point it out about a foot away from you. You'll be able to smell it quite well enough to be able to say what it smells like if you need to. Now, the only part of the investigation that is okay for you to really do, if you need help describing what salt looks like, you may go to your kitchen and look at your table salt. If you have trouble identifying what tap water looks like, you may go get a glass of water from your kitchen sink. And although I'm sure we've all done this at some point, if you're having trouble describing what it looks like to dissolve salt into water, you may take some of that table salt and mix it into your glass of water. However, if you do that science experiment on your own, you need to make sure that you then pour it down the drain. Please dispose of it properly. And absolutely do not go any further than that. There is some danger involved with the rest of the steps. So you're welcome to mix some salt into water, but then please dispose of your salt water. When you are all done with this lab, you will eventually need to hand this in. But I suggest that before you submit your lab, you take your quiz. So have your lab open, your lab observations open, have your unit notes open. When you take the test, it's a multiple choice test. Most of the questions are multiple choice. There are 5 questions. The first 3 are multiple choice. I'll give you an example of a change. You need to just tell me if it's physical or chemical. Then I'm going to give you an example of a change. It's multiple choice. You'll tell me if it's physical or chemical and why. And then the third question, again, I give you an example of a change, and it's free response. You need to tell me if it's physical or chemical and why. You only get 1 shot of this, so please take your time. Please use your notes from the lab and from class. Anyway, that's all that we did today and Thursday in class. Remember, I'm available not only on Wednesdays, but during the student support periods as well. And I hope you guys make safe choices and have a good weekend. Bye.